In this video, we'll talk a little bit more about rational functions and their properties. So the first thing that we'll need to define in order to be able to talk about rational functions is this thing called a polynomial. Now we've dealt with these already, so it's not really anything too new, but we will describe a polynomial could be a linear function and it could be a quadratic function. So a polynomial can be either of these in terms of ones that we've already studied. A polynomial is any function with variables containing positive, whole-numbered exponents. All variables are in the numerator and not the denominator. So in other words, I should say a polynomial expression is this thing. For example, if you have an expression that's 2x plus 3, which is a linear function, well, the exponent on x is 1, which is both positive and whole-numbered, and it occurs in the numerator. Same thing with 2x squared plus 4x plus 3. Anywhere where there's a variable, the power of the variable is a positive whole number. Well, what kinds of things aren't polynomials then? Well, for example, 2 divided by x in and of itself is not a polynomial, because although you have x to the first power down here, it is in a denominator. And if you were to reverse this thing, remember that 2 over x to the first is the same thing as 2x to the negative first. That's where you get to basically flip your ratio and change the sign of the exponent. So that would in this case be a negative power, and that doesn't qualify. So linear and quadratic are really the only ones that we're going to be looking at so far. And I wanted to define that because a rational function is actually more formally defined as the ratio of two polynomial functions. So it could be linear over linear. It could be linear over quadratic. It could be quadratic over linear. Or it could be quadratic over quadratic. So in terms of what we've talked about so far, now there are functions that are called cubic, and a cubic would look like this. It would be, for example, 2x to the third plus 4x squared plus 3x plus 1. So that would be a cubic because its highest power is a 3. Quadratic, highest power is a 2, hence the reason why we call it a quadratic. So these are possible rational functions. So for example, 2x plus 3 over 4x plus 4 would be a linear, a rational function. Now you might say, well wait a minute, that's not a polynomial. You're right, because it has variables in the denominator, this itself is not a polynomial, but it's a ratio of a polynomial and another polynomial. So that's what we refer to when we mean the ratio of polynomials. Similarly, a linear over quadratic could be something like this. That would be a linear over a quadratic. Or x squared plus 8x divided by x. Well, that's a quadratic over a linear because the biggest power is a 1 here, and that's what we mean by a linear function. Quadratic over quadratic, well, you can take the ratio of two quadratics, and there you have it. So that's what a rational function is. Now, a rational function does not have a beautiful characteristic where the change in the rate of change is constant or the rate of change is constant. It's not quite as pretty as the linear and quadratic and exponential we've been dealing with so far. But it is a ratio of the two. Now, vertical asymptotes, as we know from the last set of videos, occur for values that make the denominator equal to 0. So for instance, if we have 3 over x plus 1, the vertical asymptote would be, well, what makes this denominator 0? Well, if you said x plus 1, when does that equal 0? And that would be when x is equal to negative 1. So that would be our vertical asymptote in that case. We'll come back to some examples of finding these. I just wanted to remind us that that's how we would do it. Order is another word we'll need to talk about. Order is the value of the largest variable's exponent in a polynomial expression. So let's say we have 2x plus 3. Well, I'm going to always put powers on all of my variables, even if they're just 1, so that I can see that, hey, the value of the largest variable's exponent in a polynomial expression, by largest we mean the one with the biggest exponent, and this guy would be of order 1 because it has its highest exponent is 1 on the x. What about x squared plus 4x plus 3? Well, in this case, the variable with the biggest exponent is x squared, and so this guy would be of order 2. So higher powers dominate lower powers.